Merhabalar, ben Volkan Yıldız. Starwood firmasında mimar olarak çalışmaktayım. Gönül isterdi ki her yıl olduğu gibi sizleri şehrimizde ağırlayalım, sizlerle yüz yüze tanışma ve sohbet etme imkanı yakalayalım. Ama bu sefer izninizle ben size misafir olmak istiyorum. Starwood, 1750 çalışanı ile yonge levha, medefe, melaminli ve boyalı levha üretimi gerçekleştiren sektörümüzün 3 büyük sanayi kuruluşundan birisidir. Asıl gurur duyduğumuz kısım ise çevre, eğitim, enerji ve sosyal kültürel alanlarda gerçekleştirdiğimiz sosyal sorumluluk projelerimizdir. Bu kapsamda yapılan elektrostatik filtreler, tehlikeli atıkların bertarafı, 6.000 öğrenci kapasiteli Hacı Sevim Yıldız Eğitim Külliyemiz ve son olarak çalışmaları devam eden Sultanahmet Camii restorasyonu bu projelerimizden bazılarıdır. Starwood I Am Design'da tıpkı diğerleri gibi geleceğe dair çok büyük umutlar beslediğimiz ve bu yıl 7.sini gerçekleştirmenin mutluluğunu yaşadığımız bir projedir. Geçtiğimiz yıllar boyunca 40 üniversiteden 240 farklı öğrenci ve hocalarımız ile fabrikamızda atölye yapma, 4.000'den fazla katılımcıyı seminer günlerinde ağırlama imkanı yakaladık. Karşılıklı fikir alışverişini ve bir şeyler öğrenme fırsatını bu sene yüz yüze yapamayacağımız için üzülsek de enerjimizden hiçbir şey kaybetmeden etkinliğimize sanal ortamda devam ediyoruz. Ülkemiz mobilya alanında bir dünya markası olma yolunda hızlı adımlarla ilerlemektedir. Her geçen gün artan ihracat rakamları iyi yolda olduğumuzu gösterse de marka olmak için daha nitelikli ürünler üretmemiz gerektiğinin farkındayız. İşte buradaki anahtar kelime ise tasarım. Bu sebepten dolayı bu proje bize ilk geldiğinde çok heyecanlandık. Sektörümüzde tasarım yetisinin artması, kaliteli ve katma değerli ürünlerin ortaya çıkması ve bunları gerçekleştirecek tasarımcı arkadaşların sektörümüzde yer alması bizler için çok umut vericiydi. Starwood I Am Design etkinliği sayesinde bugün birçok arkadaşımız gerek serbest olarak gerekse firmaların bünyesinde tasarım hayatlarına devam ediyorlar. Seyahatlerim esnasında bu arkadaşlarla karşılaşmak, onlarla sohbet etmek beni mutlu ediyor ve firma olarak bunun bir parçası olmaktan gurur duyuyoruz. Önümüzdeki yıl sizler ile yüz yüze tanışacağımızın heyecanı ile kendinize iyi bakın. Beni misafir ettiğiniz için teşekkür ederim.
Tekrar merhabalar. Az önceki bootcamp oturumumuzdan sonra şimdi New York'a uzanıyoruz. Dünyanın en önemli malzeme kütüphanelerinden biri olan, belki de en önemlisi, Material Connection mühendislerinden Andrew Dent bizlerle birlikte olacak. Gene Oğuz Bey'in modere edeceği bir sohbet olacak. Oğuz Bey, ben Mr. Dent'i alıyorum yayına.
Teşekkürler Bilal Bey.
Hello there.
Hello Andrew.
So, thank you so much for having me. Would you like me to begin presenting?
Yes. Now
Okay.
you are already on air for the moment.
Wonderful.
And how are you in New York for the moment?
We're good. I was supposed to be here with my library behind me, but unfortunately, we have a person who's close to us who actually got COVID. So we're currently working out whether we need to quarantine or not. So I may be stuck in my apartment for the next 10 days. So we'll see.
No problem. The main issue is we have to take care of ourselves. Then after we can carry on our business everywhere.
Yes, understood. Yes.
So, Andrew, we have already visited your company in New York 2019, around October. Mm-hmm. And beforehand, we already heard, but when we came there, we really enjoy with your library. You are offering to every sector, every industry, very different ideas, and also you are not only supplying or giving the idea to industry, also you have some genius that you are calling guys there, and one of genius of course you. So me and of course my audiences is really wonder. Can you please talk about more material connection? What is the main mission of the material connection? And I would like to give the season to you, and you can please explain us material connection.
Sure, of course. What I'd like to do is to start a presentation. So if I can share my screen, I will then, and I'll give you a little bit of a background about Material Connection, and I'll talk about sustainability as it applies to furniture. So
I appreciate, yeah.
There. Okay. Here we go. Okay, so my name's Andrew Dent. Thank you so much for letting me present to you and to allow me to sort of deliver this information. So I work for a company called Material Connection. I have done for the last 20 years. We are a resource that provides information and access to samples for a wide range of sustainable and innovative materials. As you mentioned, we deal with a wide range of different industries. Everywhere where design is considered important, whether it's footwear, furniture, consumer electronics, sportswear. We deal with architecture, automotive, and also furniture as well. And what we found is there is a cross-pollination, a connection in the way that we use materials, depending on whether you're designing a chair, whether you're designing a car, whether you're designing a washing machine. All of them have connections because they're all connected via materials. So we understand that all are using similar types of materials. So there are ways in which we can help someone working in footwear by showing the materials that are perhaps currently used in automotive or currently being used in home furnishings. So that's the way we found value, is by connecting these different industries through the use of materials. Now, the main physical location of Material Connection, it normally has a library. This is an example of our library in Denmark. And you can see what we have are what we call materia tabula. They are panels which show samples. This is our system. So we organize our materials based upon what they're made of, their composition. But we also like to make sure that they're accessible in different ways as well. So we have about 10,000 currently available samples of materials displayed in this way in our location in New York, and also locations around the world. We have locations in Europe and also in Asia. So the system itself is also connected to an online database. We're able to access information about each of these materials, whether it's how it's made, what it's made of, what it's currently used for, what are some of the testing results that you have for each material, and of course, the manufacturer. Direct connection through to the source, the company that makes the material. So it's a directory or a library of innovative and sustainable materials where you can immediately call up or email the manufacturer, get samples, or order materials. So that's the library system itself and the way that we work. We work with all sorts of different brands. So think about all of the major sort of global brands out there, whether it's for consumer electronics such as Apple and Google and LG Chemical and Samsung, whether it's fashion houses such as Chanel or Louis Vuitton or IKEA or Hermes or H&M. All sorts of different brands within fashion. We work within automotive, Tesla, GM. We work within furniture brands as well. Some of the major brands producing all sorts of different furniture. We work with all these different brands, and they have access to our library, but also we work on consulting projects, trying to find them innovative and new materials. Okay, that's a bit of a background about who Material Connection is. We have our research team in New York City, but we also have researchers around the world as well, including places like Japan. We have them in Thailand. We have them over on the West Coast. We have them in Europe. So we have researchers who are looking for materials on a global scale, all sorts of different materials that are suitable for us that work in the design industries. So what I wanted to talk to you today about was, I'm going to talk through sort of sustainability as it relates to furniture design. I want to go through a number of different topics. So I want you to pay attention. There's going to be a lot of information I'm going to deliver to you, but I want to at least sort of kind of cover a wide range of different areas that I think are important that you know about if you're thinking about sustainability within furniture design. We're going to go through circular economy. We'll talk about some new natural materials. There's a lot of new alternatives to leather. A new interest in waste materials, things that are the waste either of our current household waste, or whether it's industrial waste, construction waste, all of those can be used. Digital manufacturing, how do we manufacture in a more efficient way? And then also, how do we perhaps improve our current materials through better performance, but how do we then get that more sustainably? And then also water. We need to ensure that we have good, clean water to drink and use. So how do we reduce the amount of water that we have within our manufacturing process to therefore allow more of it to be available for us as humans? And at the end, I'll take some questions, and hopefully I'm going to answer some of those. Okay. Let's start with circular economy. For those of you who are not sure what circular economy is, it's the next generation after the sort of basic idea of sustainability. It was based upon the idea of all materials are either biological or technical. Biological materials, you are grown, you use them, and then they go back into the land. They can go as compost. They compost or degrade. Technical, they're produced, and these can be things such as ceramics and metals and glass, synthetic materials, which then get produced, get used, and then go back into the system through recycling. So this is the basic idea of circular economy for materials. And what we've seen as circular economy now has been modified to be our whole design and manufacturing process. Materials come in, we design with those materials in mind, we produce, we distribute and then use. And then the idea is ultimately those materials need to go back into the system. So rather than it being a linear process of get the materials out of the ground, use them for our product, and then end up on a landfill, can we find ways in which we can put them back into the system? That's what circular economy is interested in. And a simple example, the reason why you've got differences between circular economy and sustainability, I take egg cartons. Okay, so in general terms of sustainability, carbon footprint, every time the expanded polystyrene plastic egg container is better because it has a lower carbon footprint. But if we're looking about circular economy, at the moment, there's no way to put that plastic egg carton back into the system. There's no recycling of polystyrene, expanded polystyrene at the moment. So therefore, even though the pulped paper version is a higher carbon footprint, we have effective recycling of that, and we can put that back into the system. So therefore, it's not as simple as what has the lowest carbon footprint, because then you'd use the plastic styrene expanded foam container for your eggs. If we think about circular economy, we need to use materials that can go back into the system. So that's where there is a slight difference between sustainability, which just thinks about carbon footprint and impact on the earth, and circular economy, which thinks we need to put things back into our system. We can't just landfill them or leave them out there in the environment. If we think specifically about plastic, millions of tons of it, 78 million tons. Most of it goes to landfills. Some of it goes into the ocean, which is not great. Only a tiny amount actually ends up going back into recycling. So we're trying to improve that. We're trying to get more materials. So in improving circular economy, we want to get more materials back into the system. We can recycle, and there are ways we can effectively do this. This is a cartel product. It's a chair that uses 100% recycled content. So that is using, but it needs a single source. In this case, it's polyester. And the polyester comes from things such as beverage bottles. So this is tend to be a high value recycled material. You can get good coloring, you can get good strength. It's a single source, so the material looks high quality and sell for a high price. But the majority of plastics aren't like this. A lot of them end up as sort of lower value plastics. They get mixed up. And you can, if you mix up plastics of different colors, you end up, unfortunately, with a mixed up color, or ultimately you end up with sort of darker, murky colors. So this is perhaps a lower quality, but this is still plastics that we can we get from our recycling stream and can be used. Then we go further down the chain, and you have materials from not just say plastic bottles, but then also the flexible packaging that we're currently seeing, whether it's your mixed nuts or whether it's your washing detergent. They're using flexible plastics. Flexible plastics can now be recycled into this product, which are well sorted. So they have products out that was using that, or unsorted, including a lot of waste materials for things such as this. So we are now starting to see where we can use some of these even low value plastics, put them back into the system and end up with viable products. Here you've got a durable mat which you can use indoors and outdoors. It's a great use of the plastics you typically wouldn't be able to use to manufacture into a high quality, beautiful green or white or other colored chair. This is the material that ends up as floor mats, still as essential and still a great way of reusing that material. There's also a lot of materials that unfortunately end up in the ocean. I mean, if you look at the ways in which our plastics end up in the ocean and last for many, many years. looking here at the number of years that say a 6-pack plastic ring ends up for 400 years. So most of the stuff we're putting in there, even a coffee cup can end up in there for 30 years. Not a good thing. So what are we doing in circular economy as a way of changing this? Well, there are some plastics which do degrade quickly, but there aren't many of them. This is basically a good example of those 3 plastics which degrade quickly. Rayon, which is the sort of your satin shirt. So rayon it degrades quite quickly. Cellophane, which you use sometimes as food wrap and also used in packaging for certain things, that degrades quickly. And a not quite commercialized, but just about start being used type of bioplastic. Those are the only 3 plastics, synthetic materials, which degrade quickly in the ocean. Everything else takes years. And unfortunately, we're not making a whole bunch of furniture out of these plastics currently. So that's our challenge. We want to make sure no plastic currently degrades quite quickly in the ocean, apart from these 3. So you can't expect your materials to fare well in the ocean. So we need to collect them from the ocean. Okay, so what's in the ocean? A lot of fishing nets, a lot of beverage bottles, jars and containers, cutlery, toys, and food wrappers. There's a whole bunch of different stuff. Of these, the most easily collected are fishing nets, for the simple reason that if I'm looking to try and reclaim materials from the ocean, if I grab one side of a fishing net, just like in my hand, I can reel in up to 50 kilograms of plastic. However, if I put my hand in the ocean another time and I pick out a bottle, the bottle weighs a few grams. So it's much more efficient and effective to recycle things such as nets, because you can get a lot more plastic for a limited amount of effort. And there are a number of different companies who are using these resources from the ocean. And they're being quite successful in collecting those materials and then recycling them and putting them back into products. There's also what's called ocean-bound or near-ocean plastics. So better than taking the materials directly from the ocean, it's better if we can actually collect them before they get to the ocean. Because not every infrastructure, not every country has very effective recycling and waste management. So a lot of the plastics end up on the street, out in the field, and the beach, and eventually they end up in the river and then in the ocean. So these locations we can actually find. It's possible to collect materials from these, so actually you can collect them before they go into the ocean. So there are ways of actually picking up the plastic before that. Nylon's the main one. We can make things such as, we can make molded plastic parts from nylon from the ocean. We can make other high quality products from other plastics that come from the ocean, high density polyethylene as well. So there are resources from the ocean. We can collect them. Better that we don't actually get them in the first place, but at least there are ways in which we're doing this. I'd also like to sort of talk a little bit about something called chemical recycling. Now, this may seem a little bit technical, so I want you to bear with me and to look at this. Okay, so if we start at the top left-hand corner, that's all the oil being produced in the world, okay? From oil refineries, whether it's located in the Middle East, whether it's in Russia, whether it's in the US, we have an awful lot of oil available to us. Now, a lot of that goes directly down into gas for the cars. But if we go towards the right, we end up starting producing plastics out of it. So plastics that end up manufactured into packaging, but also chairs and other types of furniture, all of our plastic products. Now, the way that happens is it goes from monomers to polymers to plastic resin. So basically you go along from left to right, you end up with your plastic products. And those can be bottles, but they can also be any other large products as well. Typically at the end of their life, they get disposed of. And if you go in that circle, the yellow-green oval, you can see that it's possible to chemically recycle plastics back into their original monomers. Now, what that means is, okay, current recycling is you chop up the plastic. So you get your chair, let's say it's your plastic chair, and then you chop it up. And then you melt that and you make it back into another chair. The problem with that is that you lose quality of that plastic. If you chop it up 5 times in a row, your plastic is not going to be good enough quality to make another chair out of it. So mechanical recycling, chopping up of plastics and melting, you degrade the plastic. It's never as good quality. Chemical recycling, you put it in a solution and you pull it apart quite gently, and then you can manufacture products and you end up with material that goes back into what we class as a virgin plastic or a completely new plastic. There you have the same quality of plastic as you had if it directly came out of the oil refinery. So chemical recycling is giving us an opportunity to recycle our plastics many, many times. So that to me is a great innovation, and we're starting to see more products being used out of it. This one's just an example. It's a US company that's manufacturing recycled plastics, but chemically recycling them, and therefore coming up with a very high quality material that can be recycled an infinite number of times, many, many, many times. Okay, that's a little bit about plastics and sort of where we are with that. And I want to talk about natural materials, things that can be grown. Now, the reason why we like grown materials is they are renewable. We can grow them again and again and again. And every time they grow, they suck in carbon dioxide. So these are, it's preferred to use natural materials if we can. We will use plastics when we need to, and we will try and recycle them, and there are good ways of recycling them, but natural materials offer a better way forwards if we can use them to their best ability. So we can find alternatives in fabrics. Things such as hemp and what's known as regenerated cellulose are ways in which we can get viable alternatives to cotton materials. Now, I know cotton is a natural material, and I love cotton. I'm wearing cotton right now. In fact, almost everything I'm wearing right now is made out of cotton. But we also need to understand it's a monoculture. And also it's quite water intensive. So we need to find alternatives, and they're now getting alternatives. Things such as hemp, things such as regenerated cellulose allow us to reduce the reliance upon cotton. So it gives us an alternative, perhaps use a little less water, gives us a chance to diversify the resources we're using. We've seen products made out of flax. Flax is linen. There's an awful lot of linen being produced in Europe, and we can produce very high performance composites. This is a Tesla electric car, and they produce the entire outer body panels with flax fiber. The fibers themselves are very good at damping vibrations, so they're good for things such as cars which vibrate when they're driving on the road. Actually, they're better than carbon fiber for actually absorbing those vibrations and making it a smoother ride. We're starting to see them used in furniture. We're starting to see them used in sports equipment, and here also in automotive as well. The challenge is you're always going to have that sort of color, because with a lot of natural materials, they tend to have the color that they're grown in. So flax fibers tend to be a slight light brown. You could color it to a black, that's fine. You can color it darker, but it's harder to get a little lighter. But at least it shows you can get high performance materials from these natural fibers. Rattan can be plastic infused and make beautiful, beautiful things for furniture. It produces rods and sheets and formable pieces. But the idea is that you use the lightweight rattan and then you infuse it with plastic. You know, this is using a natural material. Of course, we're adding in a little bit of plastic. If you use a biodegradable plastic, then that can be biodegraded at the end of its life. But it gives rattan a much more modern and much more high performance look. We've also seen a lot of natural fibers and bioplastic composites. Here in lighting, so you can injection mold or produce, thermoform, produce in the sort of standard manufacturing way, materials that have a much more natural look, aesthetic. But I used an awful lot of natural fiber as well as a bioplastic. So removing the gas or oil-based plastics, using bioplastic, using natural fibers, and those fibers can be all sorts of different things. We can use wood fibers. We can use rattan fibers, bamboo fibers. We can use flax fibers. They'll have different properties, but in an application like this, where you're not expecting something to have incredibly high strength, it's simply just going to hang there, then this can be used all sorts of different fibers. We can use waste fibers from an existing agricultural process. We don't need to use virgin. We can use things that would normally be discarded. Can we use little bits of waste material from wheat production, from barley production? Those fibers can be incorporated, added into this type of plastic, and reduce the amount of plastic materials you used, and by using a bioplastic, reduce completely the need for non-renewable oil-based plastics. We've seen that again with injection molding. This is actually a company called Sulapak over in Finland that's producing beautiful, high-quality molded plastics using the same sort of idea. Cork for a long time, because we're using fewer and fewer cork in bottles, the cork industry needs to find alternative ways of using it. Now, the cork trees themselves are renewable because they remove the bark from the cork tree every, I think, 9 years, and it does not harm the tree. It makes it look a little bit naked, but it doesn't harm the tree. They just remove the cork bark and they use that, and then the cork tree continues to grow. It just grows the bark again. So these are, so we can use these types of materials. In this case, it added in with a rubbery material, but again, using natural materials, natural cork, and the sort of lovely feel and effect you get from cork, which is naturally water resistant and also naturally antibacterial. We can, of course, get a little more high-tech and replicate or mimic or sort of recreate the effects of the performance of spider silk, but in a synthetic materials from bio-based materials. Now, there's various different ways in which we've grown these silk fibers. We can grow them from silkworms. We simply just put the DNA of the spider into the silkworm. We produce them from goats. We produce them from in the lab, basically in a petri dish. We produce them from all sorts of different, even agricultural waste. The idea is we simply just need to take the DNA from the spider, which produce, and then allow that to then produce fibers from an existing fiber production process. It gives us much higher performance than we get from our synthetics, but it also produces a material which is renewable because we can grow this again and again. We can't use spider silk itself. Although people have manufactured products from spider silk, it's very, very hard to take that silk and weave or knit from it. So better to use synthetic and better to use an existing renewable process in order to create that. And of course, bioplastics. We've seen the growth of bioplastics and the success of the use of bioplastics over the last 20 years. It's been incredible. And bioplastics that are sourced from all sorts of different renewable materials. We have bioplastics from wood. We have bioplastics from sugar-based things such as corn or sugarcane or beet. We see also bioplastics, which I think are the more interesting ones, that come from sources that can be industrialized. Things such as seaweed, algae, and also bacteria. Because the challenge with using a plastic from corn is that if you're using this corn itself, you're taking away a food source. And that is not necessarily a good thing, because if we suddenly started producing all of our bioplastics from corn or from sugar beet, then what do we have left to eat? So we want to see more use of bioplastics that are using industrialized sources that are not food crops. Algae, bacteria, these types of things. Or even, wood fibers are fine if I can get my plastics from wood fibers, because that's already an industrialized crop. I already have large areas of the world that are producing trees. So I can use that without a huge reduction in the ability to use trees for other applications. So if you're going to use bioplastics, try and use ones which are industrialized and large volume so you don't impact food sources for others. Leather alternatives. Leather is a great material. It's very hard to beat, and it has been optimized, improved over centuries. So we now have beautiful, beautiful leathers. But there are some who would prefer not to use animal products. So we found alternatives. Now, most of these alternatives, I would say probably all of these alternatives, don't quite match up to leather in terms of overall durability. They're good, they feel nice, they look great. We don't yet have the performance which will mean that they can be used, they can be found, they can be used for literally 100 years. We have leather products that are still being used that are 100 years old. We don't yet have the alternatives that can be, that have the performance of leather yet. But certainly for applications, we're only expecting to use that leather maybe for 5 or 10 years. Or if it's going to be an application where it isn't used used very roughly. So let's say it's a wall panel. Let's say it's a dashboard that isn't touched on a car that isn't touched very much. Maybe it's a surface that's very decorative, that looks very nice, but we don't interact with it that much. There we have viable, useful applications for leather, or these leather alternatives. We've seen natural waste material used in tanning dyes. This is actually a olivin leather, which is basically they're tanning the leather from olive leaves, and only olive leaves. This to me is fascinating. We've been using chrome tanning and all these sort of quite toxic tans for a number of years. Vegetable tannins are getting a lot better. Here they're using simply just olive leaves, discarded olive leaves, to create the tan, and it can produce white as well. So it doesn't have a dark green color. It can be used any color, including white. And BMW has been using this tanned effect leather in their cars, so it shows the durability of that type of tan. This is still regular leather, but it does show we're using better, more natural tanning dyes. Fruit-based coatings. This is an Italian company that uses fruit, apple, in fact, apple peel as a basis for its for the coatings for its leather. So you can buy leather-like materials that are actually based upon apple peels. Pineapple fiber leathers. These are being used commercially using pineapple fiber that's woven in with a backing, and you end up with a leather-like material that has the same look as leather, the same feel as leather, not quite as supple as the best calfskin or the highest quality leather, but certainly the general look and feel is there. The durability isn't quite there, but certainly applications where you don't necessarily need the durability and the complete suppleness of leather, this solution is an animal cruelty-free option. Then mushroom leathers. Mushrooms have had a lot of interest over the last probably 5 years because we've seen packaging and manufactured out of it, wall panels, floor panels, and now we're starting to see leathers as well. A lot of interest in that leather. That effect is created just because of the growing process of the leather. Again, not the same sort of durability, but still a beautiful material and a great story. And then, of course, making leathers in the lab, making them through the manipulation, the control of DNA, and then using that DNA to produce or grow the leathers in the lab. So without any need to harm an animal, you're getting high quality leathers that can be produced in the lab and are, in this case, potentially as durable as the real thing, because you're simply just growing the skin part of the cow, as it were. You're growing that in the lab. So that offers the ability to get the same sort of durability as you would from regular cow leather or kangaroo leather or whatever what the animal is. Excuse me. But it's grown in the lab, so therefore can be grown potentially on an industrialized scale without any need for use of animals. Okay, those are some of my natural materials. And I want to talk about waste. Things that we normally get rid of, things that we put in the trash, that we put in the garbage, that we don't consider of any value at all. I think we are missing a great opportunity when it comes to the use of waste materials. And some designers are understanding this and are starting to create beautiful, beautiful designs through waste materials. Flock in Denmark is producing beautiful trays and other ceramic parts using recycled ceramics. Now, what they do is they take the colored and discarded waste broken chips from potteries, and they put those together and they fuse them together in a firing process that creates durable ceramic pieces, but then using almost exclusively waste material. It's very hard to recycle ceramics. For the most part, your plate, your toilet, your ceramic bath, your sink, all of them end up in the landfill, or if they're recycled, they end up in roads. They're road fill or other low quality, low value applications. Here we're starting to see beautiful applications by the careful control of the pieces themselves and then bringing them back into usable, food safe and durable and beautiful products. The recycled paper on the right, again, there's no reason why we can't use our recycled paper into other things because we're not using so much paper anymore. So the packaging paper that we're getting, we can actually start producing more viable, sort of more durable applications from those materials. The Israelis can now make plastics from household waste. So banana peels, old plastics, chicken bones, all these types of things we can actually synthesize into usable plastics. Each one of those containers was manufactured from waste from household waste, organic, plastic, other bits and pieces. They can resynthesize it and then make it back into these plastics. Color them nicely, make them into durable pieces, can be injection molded or molded in a standard way, which you make other pieces of other products. This one's hard surfaces entirely made from fish scales. Now, they don't smell of fish. They are hard, almost as hard as things such as corian or quartz or other surfaces you'd find for a work surface, whether it's a kitchen or some other surface. But they press them together and they have excellent durability. So this is almost 100% from fish scales. And there's an awful lot of fish scales out there because of the fish processing industry. They have, once the meat has been used, the meat from the fish, the scales themselves are normally just discarded. So this is a great waste resource that we're getting from that fish industry. So you can see there's a range of different ways in which we can utilize these materials that before we thought were of no value. They ended up in the landfill or we burned them. So now we're starting to see creative use of these materials and materials that you perhaps wouldn't have thought could have a second life. So, old food scraps, fish scales, this idea that, though, I think we need to rethink, and designers should always be thinking, okay, in my design, can I use waste materials? Which can I use? There's a lot of materials out there that give the opportunity to recreate my existing product instead of out of plastic, instead of out of other materials. Can I make it out of waste materials? Create the story, create a more interesting backstory about your product, make it a little more circular, and just create something that's a thing of beauty, but actually comes from something which had zero value. So there's a great opportunity there, I believe. Garments and garment recycling. What that means is I can put in the shirt that I'm currently wearing, this cotton shirt, I can put it into this recycling machine, and out comes the yarn at the end that I can knit into this sock. So the idea is the ultimate idea is I put a t-shirt in one end, it chops it up, it sorts the fibers, it then spins the fibers into a yarn, and then that yarn can then go out and end up as a new t-shirt. We're getting there. So there's a potential for an awful lot of the current textile waste that we have being now manufactured back into viable garments. So this sock, I've got a pair of these socks. They're lovely and warm. they're cotton socks, and they're knitted from 100% waste material: jeans, t-shirts, formal shirts, those types of things. And of course, larger volume, heavier, harder materials. This is I think it's a Danish company that's actually producing construction bricks from construction waste. In the same way we have garment-to-garment recycling, here we can have potentially building-to-building recycling. So taking the construction waste that would normally go to a landfill, sorting it, crushing it down, firing it into new bricks, and then goes back up as a building. So that, again, that idea of circularity. So the brick can then go, and these bricks can then be recycled back into more bricks. So in theory, you would never need to make another brick again if this was fully efficient. So again, thinking about how we can make that circular process, how we can do that, and how we can have a product made back into the same quality of product. That's the ideal of circularity. That's what we're looking for. We can always take low quality recycled material and then manufacture more roads with them, or manufacture low quality material. We want to see whether we can get it more circular, because if we take a sink, break it down, and ends up in road fill, after that road's been produced, and how do we then reuse the road? We can't. So better this circular process of keeping the quality, keeping the value in the material so it can be used again and again. What we call sheetrock or drywall, it's used extensively in construction. So it's currently the outside, it's the interior of my entire apartment is this sheetrock material. It's a mixture of gypsum, so a mineral, and then paper on the outside. We waste hundreds, thousands, probably hundreds of thousands of tons of this material. It just goes into landfill. There are now processes where we can reconstitute that, put it back into building blocks. So we can take the sheetrock, when we tear down a building, it would normally go into a landfill. Now we can actually put it back into building materials to go back into a building. Again, it's not quite sheetrock again, and not quite going back into the same product, but it's certainly going back into the creation of a new building. Again, it's a close version of circularity. Okay, we'll talk a little bit about digital manufacturing. Just because automation, although there are good things and bad things about automation, it does disrupt industries. But we have to understand that we've been doing this for the last couple of centuries. the Industrial Revolution started taking the means of manufacture away from humans and making it into and having machines. So this is a continuing process. It was going to happen. We've seen 3D printing go from a quite slow process to manufacturing processes that can be almost as quick as injection molding. This is a good example of a joist that's produced using carbon fiber and molding processes that are very, very quick. It's no longer the old process of a simple print head just slowly going from back and forth as it grows your part. We now got higher processes. We're joining it together with other processes. So this is a 3D printing with molding. So it's a hybridization, a combination. We're bringing together a slightly slower process, which is 3D printing, with a faster process, which is molding, bringing them together into creating wonderful pieces. We can extend the size of this process as well. This is a process where you can actually use a robot. Rather than printing within a box, it's now outside the box. We can now print large structures. This is a chair. This is a large structure, probably 2 or 3 stories high, that was produced as a way of showing that these pieces can be produced in very, very large formats. We've seen even the creation of apparel through robots. This is a experimental process trying to create the clothes that we wear using robotic creation. This has always been a challenge because fashion, apparel, clothing has always been a very low technology, low tech process. A lot of hands are involved in the manufacture of the clothes that we wear. This is a way of actually of making that robot based, and it's a great step forward. I also wanted to show this one. This is actually a collaboration between I think it was SolidWorks, I think, Cartel, and Philip Stark. Just as a way that they're now also using artificial intelligence to produce chairs. In this case, the idea was first of all, it reduced the material to as little as possible. So it reduced it to just its constituent, but just enough to sit on. And then it put in a whole bunch of other inputs, social needs, human needs, etc., and then had artificial intelligence sort of mold and shape that product. Now, what happened was at a certain point, it came up with the ideal solution, which is the perfect chair, which I think was perhaps around about this point. And then what's happened, Stark then said, well, that's not attractive enough. And then basically sort of made it a little more Stark-like. So you'll see it, you'll see it soon now, where it goes from this chair, which I think is optimized, okay, now we've made it more like a Stark chair. But it's interesting that we're starting to use artificial intelligence to predict how we will produce furniture. I thought it was just an interesting idea. Okay. We need to treat, coat, cover, protect our products. Now, typically, that is done through painting, coating, plating. But the challenge with that, of course, is as soon as you cover a material with another material, it becomes harder to recycle. So now trying to think of ways in which we can actually simplify that. So rather than coating or plating a product, how do we change the product so it has better performance itself? So making things stain resistant. This is actually a organic-based stain resistance, which means that it's no longer using the fluoropolymers, the kind of toxic forever chemicals. The chemicals that are used in Teflon and used in Gore-Tex, those sorts of stain resistance materials, which are great because they do protect the surface. But how do we find solutions which are organic based, so they can go back into the system, potentially recycled, without incorporating toxic chemicals into that recycling system? Can we plasma treat? Can we treat the outside of the surface of the material to change its chemistry, change its structure? This water resistance in this fabric can also be done on plastics, but it's simply the plasma treatment of the surface means that it now has soil resistant, water resistance inherent in the material itself, rather than needing an additional coating or painting to protect it. So how do we then change that material so it's just still the same material, whether it's a molded plastics, whether it's a fabric, whatever it might be, but the plasma has changed the material's surface fundamentally to make it more protective. And then sometimes we can just use natural ingredients. In this case, they're just using silk. The silk cocoons, typically discarded as waste. Now you can actually get a silk-like feel onto surfaces, whether they're fabrics or hard plastics, by coating them literally in like a sort of a silk coating, a silk coating. Then one final one is low water or waterless processes. How do we, and any manufacturer worth listening to, worth working with, is already thinking of ways of reducing water and making sure the water that comes out of that process is better, less toxic, cleaner, more usable. But there are processes. A good example is just dyeing of fabrics. It's possible to do that where you use zero water at all. The waterless dyeing process treats carbon dioxide, the thing out in the air that we're worried about. It incorporates pigment colors into the carbon dioxide, puts them into a chamber, and then that carbon dioxide, with the right sort of pressure and temperature, acts like a water. It's kind of the same as dry cleaning. And what happens is the pigment molecules infiltrate the entire bolt of fabric. What you're looking for in each of those three chambers, you've got an entire bolt of fabric. No water at all. Yet what happens is the carbon dioxide flows through the fabric very much like a water, but it's still a gas. And then it basically allows the pigments, the colors, to end up on the fabric. So you can dye an entire bolt of fabric without any water at all. Because remember, dyeing of fabrics and the use of textiles is the second highest polluter of water on the planet. First of all, it's the gas and oil industry. The second one is textiles. So if we can get textiles manufactured without using water, that's a huge reduction in the amount of water we're using. Just to add to that as well, we can also use bacterial coloring. So a way of reducing water is simply just use bacteria instead of toxic chemicals in order to dye material. So again, thinking about water, reducing that water through some of these processes. Okay, so I've gone through an awful lot of information. I know I've tried to cover as much as I could just to sort of think about sustainability. But if there's only 4 things that you remember from my presentation, I want to be these 4 things. In your designs, plan for circularity. Plan to make sure that the materials you use, the process that you use to put together your product, your furniture, it allows them to be pulled apart at the end of their life to allow for that circularity. Make sure I can reuse that material again if I can. If you can't reuse it again, make sure that that material can be composted or discarded safely. But always think about the ability to pull apart your product as a way to put it back into the system to maintain that value. Ultimately, if I then need to just sort of break down the chips of my product to then reuse and reuse again, that's possible as well. But always think about how can the materials I'm using go back into the system. Second one, use natural materials where you can. Plastics are great. Plastics are easy. But if we can use natural materials, think about ways in which you can use materials that can be grown again. It can be slower growing, such as wood. It can be very fast growing, such as grasses or things such as that. But think about where you can use natural materials. Try and find ways in which you can reduce the amount of plastics you have to use, and always try and promote materials that can be grown again and again. Consider waste. Make sure that you're always thinking about where can I use waste materials, because I think consumers, us as humans, we're now okay with kind of using waste. We've kind of got used to the idea of taking recycled materials, of taking waste materials and using them again, and then accepting them. I mean, I'm drinking out of cups that have come from post-consumer recycled plastics. So plastics that were out there in the world, were used by humans, went into the recycling system, got recycled, came back out as plastic. So, we've seen products from cow waste. We've seen products from chewing gum. We've seen fish scales. I think people are now ready to accept waste materials as still having a high value. If you can design well, if you can design quality into your product, consumers won't mind if you're using waste materials. They don't think it reduces the quality of the product. It's just an interesting, different story. So don't think if you're using waste materials, it's going to be a low quality product. You can make beauty still using waste materials. And my last one, number 4, is innovate, innovate, innovate. Think about how you can use new things. Challenge the manufacturers of the materials that you're using. How can we make this better? How can we make this different? How can we improve in this in some way? Look for new ways in which you can use materials differently. Look for new manufacturing processes. Don't assume that the material that you're currently using is the only material you can use. Always look, always try and find, and that's obviously where Material Connection as a company comes in. We love to show you new stuff. The whole point of Material Connection is about innovation. It's about sort of seeing what else is new ways of producing things, sort of understanding what's possible without thinking about, okay, well, this is the way that people have always made it. No, find a new way of making it and incorporate that knowledge into your design. So always make sure you're looking for the new. Don't satisfy with what's currently available. Think how you can differentiate your design, make it new and interesting and more circular through innovations. Thank you. Appreciate you listening. It's been about 45 minutes. Thanks so much for your attendance. I'd be happy now to take questions and answers. But I think we'll go back to hiding the screen so we can now sort of talk as a group.
Yes. Andrew, thank you so much for your kind presentation for us. And we greatly understand what Material Connection offers the industry. And I would like to ask directly, and please allow me to read from my mobile that one of audience is asked Mr. Kubilay. How efficient are these new applications? And belongs to it this question, is the energy used for this recycle and manufacturing process lower compared to current standards?
Yes, okay.
Thank you.
Those are good questions. Every new process is going to need to become more efficient. So the challenge of innovation is that if we've only made it one time, we haven't worked out how to make it the most efficient way. So yes, I would agree. At the moment, the current manufacturing processes, the current products that we are using are likely to be more efficient. They're likely to use lower energy. And if energy is your biggest concern, then certainly, there are advantages with using established products and materials. But if we don't challenge that and try and become and challenge our innovations with becoming more efficient, we're never going to progress. So it needs to be we need to sort of do both. We need to continue to improve the efficiency and use our existing materials and products, but we also need to look for new ways of doing it. So I would agree. The new materials and processes, they are challenged with becoming efficient. But let's accept that if we look at plastics as a general class of materials, we're certainly not using the plastics we first came out with. When we first came out with nylon or polyester or polycarbonate, we're not using those plastics anymore. We're using a much more efficient, a much more improved, and much more innovative version of that material. Because even the existing products that we're using now, they've innovated. They've improved their processes. They're using less water, using less energy. So we need to use both. So yes, I accept that some of these completely new products have not yet been able to become more efficient, but I want to be able to give them time so they, to give them to evolve and to improve. So we can use both. We can use existing materials and use those because we know that they are lower energy and efficient, but also see what else we can do with our new materials to see whether we can improve and perhaps eventually they might be able to become as efficient as our existing materials.
Thank you, Andrew. And as far as I understand, we have 3 minutes left to finish up our season, but we have one another question, and please allow me to read directly Miss Didenur question. She is thanking to you that that's the really effective and informative presentation. Do you have any favorite material? First question is. Second is, You explain about recycling a lot, but some manufacturers are not susceptible and conscious about environment. How we are able to motivate them? As far as I understand, Miss Dillner is the designer, and how she motivated the industry. We have 3 minutes more or less.
Okay. Thank you. Favorite material? I would say a favorite class of material. I do really love. I do love wood-based products, and the reason why is because I think it's interesting how we have seen innovation within wood for some interesting reasons. The first reason is we're using less paper. And it's interesting how an industry can improve when it has challenges. So the wood industry has been challenged with, okay, we're using an awful lot less wood because we're not using an awful lot less paper. What can we do to innovate? So wood has gone through from a very standard material through, we started to see things such as, we started to see a bunch of different new fabrics manufactured out of regenerated wood. We've seen nanocellulose, this incredible material that has wonderful properties manufactured out of wood fibers, but on a molecular nanostructured level. We started to, so for me, I love wood because it's a material that's already industrialized. We've already got enough forests to take care of our needs. We don't need to suddenly start taking away from food crops, but it still has so much more potential. We have our existing wood products, but we also have this innovative area where we're seeing nanocellulose, we're seeing cellulose crystals, we're starting to see new fabrics. We're seeing ways in which wood is being innovated. We're seeing foamed wood. So ways in which that material is old, but also completely new. And I think I want to see that happening. So natural material, but innovating in ways that allow us to see it in a completely different way. So wood's a personal favorite for me. Yes.
Actually,
are we at the end?
I have already a lot of questions, me myself, but you know the live broadcast is always have a limit. And may I send also some questions to your email ID, then we will publish on our website.
Yes.
And we are very delightful for your presentation, and we are very delightful to understand more material connection. Thank you for joining us this evening, your morning for the moment to I Am Design. And I hope we will meet again and again and make the cooperation together with Material Connection and furniture industry. Thank you for taking time with us, and we would like to say goodbye.
Okay, thank you so much. It was great being here. Enjoy being with you, and hopefully see you soon.
We really enjoy your season, and we really thank you for your presentation, Andrew. Thank you.
Oğuz Bey,
Bilal,
sizlere de
evet.
teşekkür ediyoruz. Az önce Andrew'e de teşekkür ettim ama mikrofonum kapalıymış. Dün de yaptım bunu.
Evet. Anladığını düşünüyorum. Gerçekten güzel bir sunum oldu. Umarım seyircilerimiz de beğenerek dinlemişlerdir. Teşekkürler Bilal Bey.
Çok sağ olun. Görüşmek üzere.